So we're trying to find the integral of sine cubed x cosine squared x. Now normally what we have to do is we want to have a derivative form remaining so that we can integrate properly. If we convert this to 1 minus sine squared x, we're not going to have any cosines to work with. But here, if we split this up into sine x sine squared x cosine squared x, well now with sine squared x, we can just say 1 minus cosine squared x, and then we'll still have a sine x here to work with when we derive inevitably. So let's do that. 1 minus cosine squared x cosine squared x, and sorry, I forgot my dx. Okay, so now we just do a simple matter of u substitution. If we let u equal cosine x, du will be negative sine x dx. So now this and this are going to cancel for negative du. And this will be u squared and this will be u squared. So now we're going to have the integral. We're going to bring the negative out because we just took it out here. And then we're going to say 1 minus u squared du. Now we can multiply this into that, into each one of that. Negative u squared minus u to the fourth du. And now we're going to have to do the integral for each one of these. So let's just put a little box around them. And let's go ahead and do that. So we have negative. Well, the derivative of u squared is going to be 1 over third u cubed. And then the derivative of u to the fourth is just going to be 1 over 5 u to the fifth. And now we input our minus, so that will go into here. But we can just switch those around to say 1 over 5 u fifth minus 1 over 3 u to third. And now we said u equals cosine x. So now we just plug that back in. 1 over 5 cosine 5x minus 1 over 3 cosine 3x plus c. And that's your final answer.